Hello, everyone. My name is Liang. I'm the founder of the Welsim. I'm very honored and delighted to join this meeting. I learned about the SU2 project a few years ago, and in the past year, I've delved into the features and source code. I found it's a great project, so I did some work relevant to the SU2. In today's presentation, I'll be sharing some work and result I have recently done. Through the recent exploration, I found the SU2 has many advantages. SU2 already offers a wide range of computational capabilities, especially in, but not limited to, the field of CFD. It supports both compressible and incompressible fluids, several governing equations, and turbulence models. It's compatible with both Linux and Windows. CFD computations can be quite demanding, and SU2 supports high performance computing, utilizing the MPI and OpenMP, either on the clusters or personal computers. The code is well organized and of high quality, with standardized procedures for checking the new code. Software development and community are active. Additionally, the LGPL license is very friendly to users, including the commercial software developers and collaborators like me. Welsim is positioned as a general purpose engineering simulation software, or also called CAE software. We focus on the front end only and do not develop our own solvers, but we assist in optimizing the co-workers' solvers. For example, Welsim has contributed to the source code to the SU2, and primarily at the application level. We also describe the advantages of the SU2 in our recent technical blogs, in both English and Mandarin Chinese, positively contributed to the ecosystem of the SU2. My understanding that Welsim currently is a leading pre and post processor for open source solvers. It's mainly demonstrated through our user-friendly GUI and minimal learning curves for users. We are a long-term supported project, and will continue to be maintained in the future. We currently apply the SU2 as a sole CFD solver and support both Windows and Linux operating system. And Welsim is friendly. Now, as a pre and post processor, the Welsim interface, the user's interface is of importance. A wide array of controllers and widgets are required for the analysis setup. This includes menus, toolbars, different windows. All the widgets must be properly designed and to make the software easy to use. Welsim did some nice work as far as I can think. In addition, the engineering simulation always involves numerous quantities and units. The front end needs to provide a comprehensive and verified unit conversion system. Currently, we support 12-unit system and 81 units, relieves the solver developers from having to convert units. The front end also offers a flexible material editing system with more than 100 built-in material properties. Users can quickly define the necessary material data for the CFD analysis. To support the SU2 solver, Welsim provides all necessary pre-processing features. Users can easily generate the input script in the SU2 format or directly execute CFD computation. User can either import geometries from external STP files or create simple shapes directly. Automatic mesh generation is supported for creating tetrahedral or triangular elements with user control over the mesh density. After configuring analysis settings, user can find the command from the menu to generate the SU2 input scripts. By default, two files will be generated: SU2_welsim.cfg and mesh_welsim.su2, which is the mesh file. Both are in ASCII2 format. By far, approximately 200 SU2 commands have been exposed in the GUI, and which takes about 30% of the total commands. Beyond merely generating input script, Welsim also can directly call the SU2 solver, perform the CFD computation, and obtain the results. It's very easy to use SU2 for the fluids analysis. With the Welsim, the user only needs to define the model's dimension, 2D or 3D, and select the fluids as a physics type. specify whether the analysis is steady or unsteady, which unsteady is transient for me are similar. For the solver selection, user can manually specify the SU2 solver, or they can choose the program controller, which is a default setting. When the analysis type is fluids, the program will automatically redirect the solver to the SU2. SU2 provides a wide range of commands for CFD analysis. Welsim has supported most of them in the form of front-end properties. These properties include governing equations, turbulence models, gradient models, objective function, energy equation, etc. It also offers setting relates to CFL criteria, multi-grade settings, and solver convergence parameters. As shown in the right image, the properties window shows the study settings offers numerous properties related to the CFD and the SU2. Depending on the user settings, some additional property will show up also. In the context of CFD settings, one of the commonly used configurations in SU2 is a free stream field. The Welsim has a well-designed feature for this. When a user adds a free stream field object to the project tree, then select this object, then the properties window will display the relevant parameters as shown in the right picture. The supported the properties include Mach number, angle of attack, pressure value, temperature value, etc., and Reynolds numbers. The setting corresponds one-to-one with SU2 commands, making it easy for user to familiar with SU2 commands, and also the new users who can quickly get started. SU2 contains many boundary conditions for CFD analysis. Welsim also did some work as well in exposing these conditions in the GUI. The supported boundary conditions include Euler, field, symmetry, inlets and outlets, etc., as shown in the right top picture. For relatively complex boundary conditions such as inlets and outlets, the Welsim also provided an easy input method, as illustrated in the right bottom picture. Users can select a type property to specify the different subtypes, such as mass flow, velocity, and so on. Post-processing for SU2 is supported as well. Welsim reads and displays the simulation results, achieve the seamless integration with SU2. Users can perform CFD computing and evaluate the result within a single software environment. When the Welsim called SU2 executable, the solving is completed. It's able to visualize the contour plots in the 3D window for the common results like pressure, velocity, Mach number, etc. It's not only displaying the steady result, but also handles the transient analysis results. Additionally, it supports view and generate animation videos for unsteady problems. Unlike most other engineering simulation software, Welsim exposes the regression systems to the end users, both end users from solver developers. Both end users and solver developers can easily create test cases, execute them to ensure software stability and maintain the confidence in the computation. Additionally, all test cases are open source, enable the user to submit their own test case and benefit the entire simulation community. Test cases for SU2 are continually being added and maintained. Users can add can find out this command to run the regression test easily from the tools menu, as shown on the right picture. The test not only checks the feature of the GUI, but also verify the solver's results. Creating test cases is very straightforward. Users can directly create test cases by recording GUI actions. After recording, they can remove some unnecessary steps and save the file as a test case file. All the test files are in the readable XML format. The primary keyword that the WS event is for driving the operations, and WS check for checking values. In terms of the verification, you can compare the max and minimum values of the contour result with a given reference. Yeah, the conclusion after some development and testing, my conclusion is that SU2 is outstanding, stable, and precise CFD solver. with active community and ongoing software iteration. Pre and post processing developers can easily work with SU2 without significant technical challenges. Welsim is an easy to use pre and post processor, and it will keep contributing to the SU2 code and ecosystem. And I believe that we can help more users from industrial sector to get to know and understand SU2 and making contribution to the both simulation and open source community. As always, Welsim has limitations, and currently we only support the STP format as imported shapes. For the mesh generation, we only supported automatic generation, and elements only supported for tetrahedral and triangular elements. No standard analysis available yet. Welsim is a long-term support project. It will continue to provide support for the SU2 solver and CFD features. I will keep contributing to the SU2 codebase and focus on application level. More features related to SU2 may be added, such as adjoint analysis, multi-zone, multi-physics, shape design. And I learned some new features today from other speakers. And maybe I can try some expose some features related to that. Then the post-processing will be optimized as well to better fit the CFD characteristics, such as some 3D rendering features. More regression test cases will be added to ensure the stability and the compatibility with SU2 solvers. So yeah, that's all I have. Thank you for giving me this opportunity to present my work. Also, thank you for building SU2, and I look forward to keeping working with SU2.
Thank you very much. We have probably for one question.
It's only triangles and tests.
The question refers to the mesh generation, and this is asking if there is any boundary layer capability.
Not yet. That's a good question. Maybe I should put in the development plan and to realize this feature. Yeah, not yet.
Okay.
Yeah, thank you.
Is it free? Open source?
It's not open source. It's not free yet. But very friendly to the users and the collaborators. I think for SU2 community, I think we can talk about that. If you need collaborator license, I'll be really happy to offer that. Yeah. Yeah, just send me email and I'll send it to or through the foundation. Yeah, we can talk more detail because this is a very initial communication between me and the meeting and foundation. So yeah.
Yeah. There is one more question.
Do super fast. How many people work in the company, and if you can provide it for free for educational use?
So there are two questions. One is how many people work in the company, and the second one, if there is the possibility to release it for free for educational purposes.
Currently, I'm the only one full-time. Yeah, I can, kind of main person working on this project. Free, there's no plan for now because there's some other vendors provided some good free software also already. Yeah, I'm not sure. I don't think it will be free for everyone, but could be free for some collaborators and some we know each other very well. Yeah.
Okay, thank you.
Thank you so much. Yeah.
Okay, thank you so much for your talk.
Yeah.